Sines. We're going to use law of sines and we're going to use law of cosines to solve non-right triangles to find sides and angle measures. We are going to be looking at oblique triangles. We are going to be able to solve them if we have at least one side and any two other measures, whether we're talking about sides or angles. We're going to need to sometimes use law of sines and sometimes use law of cosines. So on the left here, you see law of sines. When we have angle, angle, side, angle, or side, side, angle, we are going to use law of sines. When we have side, angle, side, or side, 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 we're going to use law of cosines. If you can remember that the SAS is with cos and the SSS is with cos, then the others are with law of sines. Now, down here, side, side, angle is circled and starred because this is the one that's a little bit tricky. There can be 3 different answers. We will see later that sometimes you will have no solution, sometimes you will have one. You can draw one triangle and label all sides and angles, and sometimes you will have 2 triangles. We'll take a look at that in a little bit, but you might want to note that. So on this next page, let's make a few notes. Law of sines: if any triangle ABC where A over sine of A is equal to B over sine of B equal to C over sine of C. So the little A, B, and C on top, these are all the sides. And on the bottom, these are all referring to the angles. Now, you can also set these up by writing sine of A over little a is equal to sine of B over little b, which is equal to sine of C over little c. You could interchange these. So if you wanted to say sine of A over little a is equal to sine C over little c, you can do that as you're starting to solve these problems. Just look at what you have and think, what do I need to do in order to solve? So let's try this first one. We're not looking at right triangles. We're going to draw a picture. So let's set this picture up. And we'll say that this is A, this is B, this is C. So A is 43. Big A, big B, big C are the angles. So right now we're given angle A is 43 degrees. We're given angle B is 57 degrees. And we can find angle C by taking 180 and subtracting the 2 above that were given. So we know that C has to equal 80. So we'll come over here and fill in 80 degrees. Now we need to find all of the sides. So little a, little b, little c. We're given little a is 4, which we have right here. Doesn't matter which we search for next. Let's search for b, okay, if we want to search for little b. So if we want little b, the formula is little b over sine b, and we're going to set it equal to either the a and the c, whichever stuff we have. Now we have a right now. We have that side and that angle, so let's go with a. So little a over sine of a. So we have little b over sine of angle b is 57 degrees is equal to little a, 4 over sine of 43 degrees. And now we can cross multiply. So sine 57 times 4, so let's go down here, sine of 57 degrees times 4 is equal to little b times the sine of 43 degrees, and we can divide both sides by sine of 43 degrees. And then we're going to get our answer, so little b is going to be 4.92. So little b, that's 4.92, and little a is 4. So over here we have, okay, you can't do Pythagorean theorem to find c. These aren't right triangles, so we need to set up those fractions again. So if I want c, I know I need c over sine c, and since we have the angle A inside A and angle B inside B, we can use that. But I'm going to use A since it was given in the beginning, so I'll use little a over sine of A. So if I set this up, I have little c over sine of angle C is 80 degrees is equal to little a. Little a was 4 over the sine of 43 degrees. And again, if we cross multiply and then solve for c, we will get c is about 5.78. So now we have all of the sides and all of the angles using law of sines. Let's try the next one. For this next one, we'll draw our picture. We'll do it up here. Say A, B, C. So A is 100 degrees, C is 17 degrees, little b is 8. So I'll say big A is 100, B we don't know yet, C is 17. We're first going to find angle B because we already know 2 of the others, so we'll do 180 minus 100 minus 17. So angle B is 63 degrees. Okay, now we're going to try to find the sides. If I want, doesn't matter which I try to find first. Let's say I want to find little a, okay? So if I want little a, I need to use a over sine a. And let me work with something that I have. So right now I have angle B inside B, so I'm going to use that little b over sine of B. So we'll have little a, we don't know, over sine of angle A is 100 degrees is equal to little b is 8 over sine of angle B is 63. We're going to cross multiply. So we'll have a times the sine of 63 degrees is equal to 8 times the sine of 100. Oops. 8 times the sine of 100 degrees, and we divide by sine of 63 degrees. So little a is equal to about 8.84. So we'll put that up here. Okay, then lastly, we need to find the last side. So we'll do that in green. So we need c. So if we need c, we want to do little c over sine of angle C. So sine over 17 is equal to, I'm going to go with b again because I don't have a decimal. So little b is 8 over sine of angle B is 63. And if we cross multiply, right, sine 17 degrees times 8 is equal to sine of 63 times c, and then divide itself for c, we're going to get that little c is equal to 2.63. So we have all sides, and all angles. Let's continue